The hardest problems of Chapter 7, that's problem set 3B, are these subsidy problems. And they fairly closely follow an example at the end of Chapter 7, but I've had a lot of student questions. So I'm just going to do the one that I have the numbers for. A lot of you have different numbers. It's fine. It's technique's the same. So let's start by graphing this problem. We're given quantity in millions of gallons per year, price in dollars per gallon, and then we've got this demand curve that runs from 6 to 6. P equals 6 minus 1 Q. Y-intercept is 6. Slope is -1. So my x-intercept is also 6. And then the government is buying fuel oil abroad at $2 a gallon. This is just the world price of fuel oil. But then the government is subsidizing the purchase of fuel oil to the tune of $1 so that citizens can buy it for PW minus 1. So let's calculate welfare effects here. We've got consumer surplus. There's going to be no producer surplus, but I'm going to have that row anyway. Then government revenue is going to be a new area of surplus, and then a total. Then let's look at the free market case, and then let's look at the subsidy case. Then let's look at the change, and we'll just make a nice little table here. Not a very pretty table given my poor drawing skills, but it'll do the job. Let's do the free market case first. Oh, I've got to label all my areas. At 2, consumers would have bought 4 million gallons in aggregate. At 1, they buy 5. A, B, C, D. All right, consumer surplus under the free market is just A. Producer surplus is 0. There's no domestic producers. Government revenue is 0. Total surplus is A. Under the subsidy, now consumers just pay 1 instead of 2. And so consumers get A, B, C in consumer surplus. There's still no producer surplus. Now there's a government expenditure. So a revenue counts as a positive because the government can use revenue to provide goods and services to citizens elsewhere in the economy, or just transfer it depending on what the government's doing. But when the government's got to spend money on a program, we count it as a negative because the government's going to have to tax people elsewhere in the economy to raise the funds to run this program. And they're going to pay $1 a gallon for 5 million gallons. 1 times 5 is this area BCD, and it enters in as a negative BCD. Let's look who wins, who loses. Consumers of gasoline get more gas at a lower price. They pick up areas BC. But then taxpayers, who maybe are the same people, they didn't used to have to pay any money to support the goings-on in the fuel oil market, but now they're out $5 million. So when we add up total well-being under the surplus, under the subsidy, positive B, positive C, negative C, we're left with A minus D, and then we can see as an economy, we've lost area D. This little triangle, we're going to call that actually dead weight loss. It's the difference in surplus. The free market surplus was the highest attainable given there's no externalities. We'll talk about that in a few weeks. And the surplus shrank by the area D, which turns out to be $500,000. Now the next problem asks you to put it on sort of a a per household basis. So let's go to that. Sometimes they change the numbers around. I don't know what they did to me. Let's go see. Some of you, I think, had one function for problem 8 and a different function for problem 9. All right, so I have the same function for problem 8 and 9. Here's the graph. Remember our analysis. At 2, people bought 4. At 1, people buy 5. And then economy-wide, this is millions gallons. But we're going to make a simplification, or we're going to, this is a can problem, and they say there's going to be exactly 1 million households in the economy. So we can divide everything by a million to get it on a per household basis. So let's remember A, B, C, D. Remember area BC was the lost consumer surplus if we ditch the subsidy, but area BCD, that bigger rectangle, is the tax cut that people can get if they ditch this subsidy program. So let's tell. All right, so how much consumer surplus would each household lose if it had to pay $2 a gallon instead of $1 per gallon? And that works out to be, this is on a per household basis, so it's $4.5 per year, just to back up. Economy-wide, it's this area BC. B is a rectangle of area 4, C is a triangle of area 0.5. So it's $4.5 million per year, but on a per household basis. We divide that by a million and get $4.5 a year. But with the money saved by not subsidizing oil, how much could the Icelandic government afford to cut each family's annual taxes if we had a perfectly egalitarian tax system, which apparently we do? Everybody gets a $5 per year tax cut. So they lose $4.5 a year in the lost surplus, but they gain $5 in a tax cut. And then, of course, you guys can do the math as well as I. Everybody's better off by 50 cents per year. But times a million, that adds up. And then I guess they ask us to point that out. What would be the aggregate change? There's several options. There would be an aggregate gain of $0.5 million per year. So the subsidy is inefficient, because getting rid of it increases welfare. That means we can conclude it's inefficient. So that's what those two problems should look like. Good luck finishing that problem set tomorrow, Sunday night, not deadline. Good luck.